Hi students, this is Unit 3 Video 2. I'm going to be explaining the diagram in your textbook on page 156. Now, you probably don't have much experience understanding scientific diagrams, so I thought I'd explain it to you, even though the textbook explains it quite well, so that there's no confusion. So here I've drawn it up on the board. Now, first thing, when you look at a diagram, you mustn't get confused about all the crazy things that are happening on all the labels. Firstly, what you must do is look at the axes, which is the vertical axis here, which is called the y-axis, you don't need to know that, and the horizontal axis, and figure out what each is talking about. Because then you'll understand, as things vary in the diagram or the graph, you'll understand what's happening. So this axis here is labeled volume, and it's measured in milliliters. So that means these numbers here, even though they don't have ml, milliliter, written after them, because it was written over here, these are all measured in milliliters. So 0 milliliters is at the bottom, then it gets more and more and more and more, up to, it's supposed to be 6,000, not 600. Oh well. Okay, so volume in milliliters is over here. So as things vary here, they go up, it's a greater volume, down, it's a lower volume. The horizontal axis is actually bad. In this diagram, they haven't labeled it. And maybe that's because there's no real label for this diagram, because it's a theoretical diagram. It's not, or graph, it's not based on an experiment. I would maybe label this time if this had been an experiment. I'll explain in a minute like exactly what the experiment would have entailed. But as time progresses, this happens, then that happens, then that happens, then that happens. So you could have time in seconds along the bottom. And then you understand that as we progress from left to right, time is continuing. So let's look at this as if this had been an experiment that they'd done. This is a diagram of the average human lung volumes. That's the title, and it's called Figure 7.3. So every diagram should have a title, average human lung volumes, label on the x-axis, a label on the y-axis, and then whatever's in the diagram. So if this had been an experiment, what would have happened is someone is breathing in and out, and in and out. And that's just their ordinary breathing. And then the person was asked, please breathe out, once they've breathed in just a normal amount, please breathe out as far as you can. That's what happened here. And then they said, okay, now breathe normally again. And maybe a few of these happened, they've only drawn one. And then they said, just when they breathed out, they said, please will you breathe in as far as you can. Then they breathed in all the way, and then when they were holding as much breath as they possibly could, then they were asked, please breathe out as far as you possibly can. They breathed out all the way down to here, and then they said, okay, now you can breathe normally. And then they carried on. So you can see how, if we'd been doing an actual experiment, time would have been progressing. First this happened, they were breathing normally, then they were asked to breathe out far, then they breathed normally, then they were asked to breathe in far and all the way out. Okay, so that's the relationship between the axes. Now we need to talk about the labels. So when the difference in volume between when you're breathing in normally and when you're breathing out normally is called the tidal volume. And according to the axes, it's the difference between 2,700 milliliters and 2,200 milliliters. So that means the volume that's changing each time is 500 milliliters. So yes, I'm correct. Yeah, that's what it's written. So the word for the volume that you breathe in and out when you're breathing normally is called the tidal volume. And then let's go to here. When you breathe out as far as you possibly can, there's a secret, you actually have still air left in your lungs. It feels like you've got nothing left, but actually there's still some air left in your lungs. And in my understanding, that's partly in your airways and in your actual lungs. They don't deflate completely, and that's called the residual volume. So you've breathed out as far as you possibly can, but there's still some air left in your lung, in your air spaces. And according to the diagram, that's the difference between 0 and 1,200 milliliters. So the residual volume equals 1,200 milliliters. So they've breathed out as far as they possibly can, but there's still air left. And then they breathe normally again. Then they're asked to breathe in as far as they possibly can, and the diagram says at that point, if I had the correct number, there would be 6,000 milliliters, that's 6 liters of air in your lungs, if you breathe in as far as you possibly can. And then when they breathe out after that, oh no, wait, I'm not right. The difference between all the air in your lungs and absolutely no air in your lungs is called the total capacity. And remember, you never breathe all of that out. It's 600 milliliters, 6,000 milliliters. You never breathe all of that out because some of it, the residual volume, you can't breathe out. It just stays in your lungs. And according to one of the readings I read, even when you die, that amount of air still stays in your lungs. It never deflates completely unless you drowned. Then it would be replaced with water. But so even dead people have this amount of air left in their lungs. But anyway, maybe you didn't want to know that. So total lung capacity is the absolutely total amount of air your lungs can hold, 6,000 milliliters, and it's the difference between when you've breathed in completely and when you breathe out completely, plus the extra air that's left in your lungs. So then the name for the volume of the difference between when you've breathed in completely and when you've breathed out completely is called vital capacity. And that's what you normally experience. Tidal volume is your normal day-to-day life, and then if you're asked to breathe in completely and then out completely, the difference between those two would be vital capacity. So you can practice now while you're listening. Breathe in and out normally, and then try, once you've breathed out, it feels like you've breathed out pretty far, but you can actually breathe out a lot further. And I experienced that when I did scuba diving. You use this volume of air and this volume of air to help control your position in the water, because air is buoyant. This you totally don't need to know, but I just thought it might be interesting. Air is buoyant. So when you've got between 2,700 and 2,200 milliliters of air in your lungs, you've got a fair amount of buoyancy. But if you were to breathe out extra, you lose that buoyancy. Buoyancy keeps you up. So you lose that, and so you sink a bit, so you can go further down. So you can breathe normally, and then if you want to, rather than using up energy to swim lower, if you just want to drift a little lower, you just breathe out even further and then do some breathing down here. So you're still breathing in and out, but it's just with less air in your lungs. And then you can go back to breathing normally, and you rise back up to where you want to be in the water. And then if you wanted to rise up to go over a rock, but you didn't want to disturb anything by swimming up, you can just breathe in and then breathe in and out a little higher. Obviously we don't do that in normal life because I guess you're not breathing out enough carbon dioxide and maybe you'd hyperventilate, but it's useful in scuba diving. And it was interesting for me to experience that you don't die when you breathe out completely. It feels like you would, but you actually don't. And if you're living up here with breathing more in and out, but higher with your lungs mostly full, you're actually fine. It seems kind of bizarre. But anyway, so what you need to know is what these four words mean. Tidal volume is the volume when you breathe in and out normally. Residual volume is the air that you'll never breathe out of your lungs. Total lung capacity is all that your lungs can contain. And vital capacity is how much you breathe in and out maximum. You do need to know the volumes. You need to know that this is 500 mils. You need to know that this is, whatever that is, 4,700, 4,800, and that this is 6,000 mils. And you need to be able to read a graph like this and fill in the blanks, even if the graph was written the other way around. If the order wasn't exactly the same, you need to be able to interpret it and read it. I think there was still something else I wanted to say, but I can't remember. So that's the end. Thank you.